in this video, we're going to be doing Calc AB, problem set 46. Problems and a playlist are in the description, and let's look at the problems. We want to evaluate the limit as x approaches 5 of x cubed minus 125 over x squared minus 25. First thing I do in my head is I just take 5 and sub it in. I get 0 on the top and 0 on the bottom, so I got to do something. I'm going to choose to do this first by just factoring. So to do that, I have to remember how to factor a difference of cubes, which is, I don't know, you do SOAP. I think that's the way I've always remembered. Well, since I've managed to remember it, it's SOAP. So it's same sign, opposite sign, always a plus. And so as we do that, you'll see that we get, so it's x, same sign, so minus 5, then x squared opposite, so plus 5x, always a plus, so plus 25. It took me, I don't know, 20 years maybe to memorize that. So I don't really expect everybody to have that memorized. You could also use synthetic division. Like you know that 5 is a 0, so divide that thing by x minus 5, see what you get. A lot of different options. You just have to decide which one you're most comfortable with. I'm going to cancel out the x minus 5s to get just this. Then I'm going to substitute 5 to get 75 over 10, and 75 over 10 simplifies to 15 over 2. Alternatively, because we did get 0 over 0, I'm going to do some bad work on L'Hopital, so I'm not going to write out the limit of the top equals the limit of the bottom equals 0, therefore by L'Hopitals. I'm just going to apply L'Hopitals, right? So derivative of the top would be 3x squared, derivative of the bottom is 2x. So our original limit is also equal to the limit as x approaches 5 of 3x squared over 2x. Plug in 5 at that point, and you're going to, well, I mean, you could cancel an x, but whatever. You get 75 over 10 again, or 15 over 2. So that's our first problem. Let's take a look at the next one. Find the slope of, or the first derivative of, y equals arctan of sine of x at x equals pi over 6. All right, so we need to find this derivative. So it's going to be 1 over 1 plus u squared times du dx. So what I usually do is I'm just going to start with the derivative of sine. So that's cosine, that's our numerator, 1 plus sine squared. However you like to write it, it's just 1 over 1 plus u squared times the derivative of u. And you got to get that down. So we're going to evaluate this at pi over 6. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. So we will end up with root 3 over 2 over 1 plus the quantity 1/2 squared. And then you just, simplify that. So common denominator in the denominator. And then ultimately that will simplify to 2 root 3 over 5. Pretty good question. Next up, the slope of the curve, or the derivative, at any point xy is given by 3x squared minus 5y squared. So it's implicit. Find the concavity, or the second derivative, of the curve as a function of x and y. All right, so that's pretty typical. So we need to find the second derivative. So I'm going to be taking the derivative with respect to x of both sides of some equation. The equation is basically dy dx equals 3x squared minus 5y squared. So that'll end up looking like the second derivative equals d dx of 3x squared minus 5y squared. Just take derivative, don't forget the chain rule. So we'll get 6x, then we'll get minus 10y dy dx, because the derivative of y is dy dx. Then you want to replace, because we want a function of x and y, we don't want a dy dx in there. I'm going to replace dy dx with 3x squared minus 5y squared. So that's going to look like this. And then I'm just going to expand. I mean, I honestly think you could be done there, but I'm going to expand it so that we get 6x minus 30x squared y plus 50y cubed. I think that's the answer. All right. Next up, find dy dx for. So this is another implicit problem. 3x squared y minus 5y equals 4xy plus 2x. So we're going to need a couple of product rules, right? So we'll use a product rule on 3x squared y. We'll use a product rule on 4xy. So I'm going to take the derivative with respect to x of both sides, which just looks like this. All right, here goes. So we're going to use a product rule. So first, 3x squared, derivative of the second is dy dx, plus second, which was y, times derivative of the first, which is 6x. And then the derivative of minus 5y is minus 5 dy dx. Equals, we're going to do another product rule. So first is 4x, derivative of the second, dy dx, plus second, so y, times derivative of the first, which is just 4. And then the derivative of 2x is just 2. All right, now we got to simplify this. So what I usually do is just go searching for things that have dy dx. and I move all of them to the left-hand side because that's just where the thing you're solving for typically goes, right? So I'm going to end up with coefficient of dy dx is going to be 3x squared minus 5 and then minus 4x because we have to move that 4x dy dx to the left. So that'll give us 3x squared minus 5. What am I doing? Yeah, minus 4x dy dx. And then move everything else to the right-hand side, right? So most of it's already there. We just have to move that 6xy to the right-hand side. So we're going to get 2, a 4y, a minus 6xy. Then I'm going to divide everything I see by 3x squared minus 5 minus 4x to solve for dy dx because that's what we wanted to do. And our final answer looks like that. So 2 plus 4y minus 6xy all over 3x squared minus 5 minus 4x. And that's the problem set. So I hope you found this helpful, and good luck.